on NumPy arrays. How do I know that it's faster than lists? Like, all right, sure, Jenny, if you're able to see this later on, right? So yeah, moving ahead back to this case scenario. Let's take a look at our current case. I can run this NumPy data or NumPy arrays, but how do I get to know it is much faster than the typical lists? The best way to do that is to compare them. So let's put them head to head in a simple operation. Here's what I'm going to do. I'm going to import time because we need to calculate time, right? Then I'm going to import numpy as np. We're not just going to import numpy. Most of the times we're going to import numpy as a short form of it called np so that we can basically perform these operations in a much faster rate. So we can just write instead of writing instead of writing numpy dot array or something, we'll just use np dot array. It's similar to how we shorten a print to IC that helps us, kind of similar to that. Anyway, let's move ahead and try to work around the next thing. Right. The next part of this, let's take a look at this. Here's what I want to do. I want to perform a very simple task. I'm going to take a very large NumPy array of 1,000,000 elements, and I'm going to take a very large list of 1,000,000 elements as well. Once we take a large NumPy array of 1,000,000 elements and a list of 1,000,000 elements, the next thing we're going to get to do is figure out which is faster. Is the NumPy array faster or is the list faster? To do that, once we take 1,000,000 elements, we're gonna multiply it by 2. Each element, we're gonna multiply it by 2, and the result will store it back in the array. And here the result will store it back in the list. That's the purpose. Let's try it out. So let's start with for I in range of 1 comma some huge number like this. This should be good enough. This particular huge amount of values, we're going to store it in a list that begins here. And I'm going to do the same thing as a NumPy array. And to create a NumPy array, you have an inbuilt function called np.array. You can create an array either using a range just like this, or you can create an array by taking this list and converting it to an array. You can perform it in any way you'd like. That's the first thing. Now that we have done this, let us print two things. Type of list and type of array. Okay, I think I took too much values. It says out of memory. Let me try again if it has refreshed the memory. No, it hasn't. Let me reduce one value. Still doesn't work. Let me reduce one more value. Okay, this. Okay, there we go. Now it works. We have reduced quite an amount of values. So yeah, we're just storing it in a list and then we're just storing it in an array. This might take a few seconds. Of course, it takes too much I'm so sorry. Again, I think there was microphone not connected properly since I rejoined. Can anyone just let me know how long I was away from the meet? Because last when I opened the browser, I could not access a web page. And next thing I realized that my browser was unresponsive. So I just wanted to ask how long was I away from the meet? Can anyone please let me know? That is, how long was I unavailable or were you not able to hear me or any such thing? Just a response in the chat window should be fine enough for me to just get to know. So yeah, I just wanted to ask this, guys. Can anyone please confirm and let me know like how long I was unavailable or how long was I not responsive over the session or you were not able to hear me because last I opened the browser and tried to open a different tab, it crashed out. Hence, I wanted to just ask and confirm. Uh, can anyone please let me know? Or is it you were able to hear me and I just rejoined and is the session still going on? Oh, I am terribly sorry. If it was 6 to 10 minutes, I am so sorry for that. Okay, this is definitely not something I expected. I was just going through a lot of things and I was continuing ahead my code thinking that I'm audible. Oh man, that's terrible, right? So yeah, I think um, I may have crashed out at this point if I'm not wrong. That is when I took too large a list. I mean, I may have ran out of memory, and that is where I would have crashed if I'm not wrong. So let me just walk back to this very quickly and work around from here so that I try to quickly work around this. So again, apologies for the delay of maybe 6 to 10 minutes. That's quite a lot of time that has gone away from us. So apologies for that. Getting back into this. Um, Again, please let me know if I'm just moving away from something and I haven't covered it by any chance. So yeah, please let me know about that. Getting back to this, I believe I took a very large list with a huge amount of numbers, which pretty much crashed my memory, even though I have 16 gigs of RAM. That's how bad lists are. So that was a 6 minute experience of never to use list. So yeah, let's get back to this in our case. So what we're trying to do here is get to know why NumPy array is faster than lists, essentially. The reason why NumPy arrays are faster than lists is because we saw that in like a visual representative before. So let's try running this. And prior to that, since I restarted this, I'm just going to use, right, we're just going to activate this and let's go ahead. Now let's run this. When I run this, you get to see here, the first is a list. The second is a NumPy array. So we have created a NumPy array as well as a list. I believe till here I was done. Can Orissi or anybody please confirm if this was the last part that you guys saw within the session where I just started to differentiate? Oh, yes, that is the one. All right, all right. So that is where it crashed then. Okay. So we have a list and we have a NumPy array. We can create a NumPy array just by a list. Once we have a list and NumPy array, what I want to do here is find out how fast both of these are. So my little operation is to take the entire list, multiply each element by 2, take the entire numpy array, multiply each element by 2. Both of this is what I want to try. Now, to do this, if you want to multiply each element by 2, there are two ways to do it. For a list, we'll use a comprehension. That is for each value in list, I'm just going to perform value multiplied by 2. That means it goes through every element of the list. That element will be multiplied by 2, and I'll store it in another variable called list2. For arrays, though, I don't have to do any of this. I don't even have to use a for loop. Arrays perform scalar operations directly. So if I take an entire numpy array, if I take an entire numpy array and multiply that numpy array by 2, like ARR into 2, each element of the numpy array will be multiplied by 2 and it's going to give me a new array. This is what we want to do. Now, let's get to see how much of a difference is there between a numpy array and a list. So I'm going to perform this 2 times. Because I cannot replicate a much larger number, I'm just going to perform the same operation twice. And here's what I'm doing. Since I've already written this code while we were out of the session, I'm terribly sorry for that again. I'm just going to walk through this and explain this. So here's what we're doing. We are calculating the current time. The current time is calculated in seconds since 1970 January 1. So since 1970 January 1, however many seconds have passed through, that is 1698276 dot something, some milliseconds, 329 could be 2. This will be calculated and this will be stored in start time. Then we'll perform our list operations. That is, we multiply the list by 2 twice. Then we'll calculate the current time again. This time the current time will be 16, just the same thing, 276. Instead of 1, it could be 7.473 or something. So we have 6 seconds point, some amount of like 147 or some sort of difference like this. 6 seconds and some amount of microseconds. This difference is what we need. So whatever start time was there, we're going to subtract it with the newly calculated time. We'll get the difference. That is the total time taken. That's how we'll get to figure it out. This is the way we calculate it a lot of times in the real world as well. A lot of real world operations, we do exactly this. We take time, initial time, we subtract start time from it, we'll get the total time taken. That's it. Now, the same thing we're going to do again, but this time it's not list operations, it's numpy array operations. We multiplied the list by 2 twice, we'll multiply the array by 2 twice, and we calculate the start time, end time, and we specify what is the total time. That's it. This is what we're going to do. So let's try this out. I'm just going to run this and let's see how long will it take. You can see the list took 1.35 seconds, whereas the NumPy array took 0.03 seconds. That's a huge difference, right? 1.35 to 0.03. That's a massive difference in terms of time. This is the reason why we end up using NumPy arrays instead of lists. I just make sure that my browser's working fine, so you can hear me. Perfect. Now I should know never to use list, a larger list when I'm in a session. So here, there we go. And that's basically how we calculate the time difference between them. Once we calculate the time difference, we get to see why NumPy arrays are faster. And this is the reason why we use pandas. And pandas has nothing to do with real pandas. It's just short for panel datas. It's just short for panel datas. That's it. It has nothing to do with pandas in reality. It's just a short form of it, just like how Python came up from Monty Python for reference. Now, Let's go on and try to see what happens up next. Now, pandas is a particular library that we use to read and perform some operations on large data sets. When I talk about large data sets, I mean it could be database entries, it could be CSV files, it could be a lot of Excel files, it could be many things that you might want to perform operations on. We basically use pandas. And that's what we're going to use now. We're going to use pandas to perform operations on some Excel files and CSV files, and we're going to try to see how it helps us, why it helps us, where it helps us. So this helps you perform a lot of operations on large files. You can perform statistical operations on it, like aggregation functions or so on. You can clean the data sets. You can perform a lot of different operations based on them. That's one thing you can just know. And that's why we have this particular package or library that we call pandas that we're going to use. So I've just specified this earlier. What is it for and why do we use it? Pandas, in short, stands for panel data. You can import SQL tables, spreadsheets, CSV files, clean dataset, handle missing values, change any data type or formats, perform aggregation or statistics. But one thing you cannot do in pandas directly is visualization. Think about this. If a client asks you to walk through their company's last 10 years of sales data, and you give them an Excel file. I've gone through them, I've calculated the thing. Just read this Excel file, you understand everything. The client won't do that, won't be able to do that, right? Nobody will be able to do that easily. So, to understand that better, I just wanted to take this example, and that's where my